So don't hand anything in today. You want to hang on to it to study from. For the last time, who's my favorite student? None of you. This might be the last time some of you see Anne. Let's take Physics 12, then she shows up again. Number one asked, how much work would it take to stop a vehicle? Well, my first thought was, I know that work is force times distance, but I didn't see a force or a distance. So in my mind, I said, nuh-uh. Then my next thought would have been, well, if they had given me a force versus distance graph, I would use the area underneath the graph. They didn't give me a graph. So I moved to what we called the work energy theorem. This was the equation that relates work and energy. It's the change in potential and the change in kinetic. Now, I like this question, but I should have included the phrase over level ground. Since they didn't mention a hill, Owen, I'm going to assume that there's no change in height and therefore no change in potential energy. Owen, what's change in anything? From my formula sheet, top left corner, what's change in anything? And so I said it's going to be a half mv final squared minus a half mv initial squared. But then it said comes to a stop. So I said it's going to be negative 0.5 times 950 times 45. Don't forget the squared. I got negative 0.5 times 950 times 45 squared. I got negative 961,875. I'm going to make the 1 a 2 and go to 3 sig figs. I'm going to write it as negative 962,000 joules. I will be fussy. I do need to see the negative. What's the negative telling me here? The car needs to lose energy to come to a stop. Now, the law of conservation of energy, Christian, says this energy can't vanish. Where did all the energy get transformed into? If it's a typical internal combustion car. Yeah, the brakes, the tires, the hubs all got hot. If it's an electric car, a lot of that can be turned into electrical energy and recharge the batteries. It's one of the reasons electric cars are so much more efficient. B says, so I would, for full marks, you know what, I'll go all or nothing. If it takes 150 meters for the vehicle to stop, what's the minimum force of friction required? Again, for friction, my first thought was, well, that's mu times the normal force, but they didn't give me a coefficient of friction, so I said I better pivot. Oh, maybe I'm going to use my previous answer. What did I just find? You said I found the heat, which is the work done by friction. This is the work done by friction, which is going to be the force of friction times distance. I can get friction by itself. What's the force of friction going to be? It's going to be negative 960. You know what? I'm going to use my answer button. So why don't I use the full value? It was negative 961,875. Negative 961,875 divided by 150. And I got 6,412.5. I'm going to write 6,410 newtons. I would take a positive or a negative here. The negative is telling you that the force is in the opposite direction of the distance, but I didn't specify magnitude and direction or anything in the question, so I would accept either one here. Part C, they want me to find the coefficient of friction. This has to be positive. So if I use my answer button, I'm going to have a negative that I'm just going to ignore. Now I'm going to say, hey, friction is mu times the normal force. I need to get the mu by itself. I need to divide by the normal force. I don't know the normal force. Wait a minute. It's mg. Mu is going to be my answer button from the previous question divided by 950 times 9.8. Was M 950? I went from memory. I might be wrong. Hey, I was right. So it's going to be answer button divided by bracket 950 times 9.8. I'm going to ignore the negative. I got 0.689. Is that right? 0.689? Yeah, the 8 would become a 9. No units for a coefficient of friction. Number 2, ooh, here's a 3-mark question. This is going to be multi-step. It wants the initial speed. What we did for this is we started out by saying we're going to use the concept of work equals work. We're going to say the force of friction times distance equals the change in potential plus the change in kinetic. This question doesn't mention a hill. I would probably try and make sure I included the phrase level ground, but this question here, I can safely say that. So, and what's changing anything? It's going to be 0 minus a half mv initial squared. Why 0? What's the final velocity of every car accident ever? 0. And they want me to find VI at the beginning. Over here on the left, I said friction is mu times the normal force, and then the times distance would drop down like a domino. I would say, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. And then I wrote it as mvi squared over 2 instead of a 1/2 mvi squared. What's kind of cool is the masses cancel. And in fact, I didn't give you the mass, so you had to do that. What means in real life is the RCMP don't even need to know what car was involved. They can start their investigation. They don't need to know how many passengers were in the vehicle, because that would normally, if mass didn't cancel, you'd have to somehow factor that into account. And I'm going to go times by 2. And, am I going to get a negative answer? No, technically right here, the force and the distance are in opposite directions. And so I could have introduced a negative right here. And what that's going to mean, Christian, is on this line, I'm going to get a positive scalar answer. The negatives would cancel out. So I'm going to go times by 2 square root. I'm going to get V equals the square root of 2 mu g d. It's going to be the square root of 2. What's mu? I don't know. What's mu with you? 0.55 times 9.8 times 52. V initial equals square root bracket 2 times 0.55 times 9.8 times 52. Close off the bracket because all of that is inside the square root. Did you get 23.7? I see people nodding. That'll get you, was this worth 3 or 4? 3 out of 3. I'm just curious what that is in kilometers per hour. Times by 3.6. 85 kilometers per hour. If you were on the low heat where it's 80, they couldn't charge you with speeding, but you might still be reckless driving, I don't know. But certainly in the subdivision, you could be charged with speeding. If you got that right, 3 out of 3. Otherwise, I would probably give you a half mark for that line, a half mark for that line, a half mark if I saw that, a half mark for the numbers. 1, 2, 3. I'd probably give you a half mark if I saw work equals work, and I'd give you a half mark for the answer, probably something like that. Number 3, I see a change in height, I see a change in speed, I see a yucky curvy path. This is going to be conservation of energy. Also, VI is not 0, so there's going to be a little bit more writing. How fast is it traveling? I'm going to say KE initial plus PE initial equals KE final plus PE final, and the only one I can cross out is I can let the ground be slide level. I'm going to go a half, change colors, Mr. Dueck. I'm going to go a half mv initial squared plus mgh initial equals a half mv final squared. Tristan, is there an m in the left-hand term? Is there an m in the middle term? Is there an m on the right-hand term? Can little kids and grown-ups go on this slide? Yep. And they'll all end up going out about the same speed in theory. Reality is going to be really different, and I'll show you that in a second. I want to get the VF by itself. You could just go divide by 0.5 square root, and I'm fine with that. What I tend to do is I actually usually end up going times by 2, times by 2, times by 2. It clears all the 1/2s out, and in fact, it's a bit of a built-in error check, because the equation that pops out is VF squared equals VI squared plus 2AD, except instead of A, I'm writing the acceleration due to gravity, and the height is the distance. And then how do I get rid of a squared? Square root. It's going to be the square root of 8.3 squared plus 2 times 9.8. Cole, how high is the water slide? 21 meters. 8. You know what? Let's do this all in one step. 8.3 square root bracket 8.3 squared plus 2 times 9.8 times 21, and I get, you get 21.9? People nodding? Laura, this is a nonsense answer, because 21.9 meters per second times 3.6. That means you're shooting out there at almost 80 kilometers per hour, which doesn't happen. Where do we lose most of our energy in a water slide? We talked about this the other day, but it bears repeating because some of you will be going on water slides this summer. Where do you lose most of your energy? Not as much as heat. I called it heat in part B, but that's not really where you're sending it to. Anybody remember? You're pushing a big wave of water in front of you, and the water, in fact, is slowing you down to a much safer level. Yeah. Otherwise, this would be pretty catastrophic, because you'd go skipping right across the pool and hit the cement on the far side, hardly slowing down at all, right? So how much energy was transformed into heat? I'm going to start off with part marks. First of all, I would give you 4 out of 4 if you found that, if you got that. Otherwise, it would probably be 1, 2, 3, 4. I'd probably go a half mark for that, a half mark for that, 1 mark, 1 mark, 1 mark, something like that. Suppose the child is only traveling at 16. How much energy was lost to heat? So it's still going to be conservation of energy. But now I'm going to include heat. I can still do that, but now I want to get the heat by itself. I'm going to move this over by subtracting. So I'll get the initial plus the initial dropping down like a domino minus the KE final. That equals heat. Heat is going to be 0.5 mv initial squared plus mg h initial minus 0.5 m v final squared. Or instead of the 0.5s, you could write a 1/2. Ooh, Alexia, do the m's cancel here? Is there an m in heat? So this time they don't cancel. Oh yeah, a bigger person would push more water, because this is really where most of the energy is going. So it's just going to be crunch the numbers, Mr. Dueck. Heat is going to be 0.5. Alexia, what was the mass of the rider? Question must have told you. I don't know. Where is it? I scrolled down. Is it 45? And then what was the initial speed coming? Was it 8.3? Squared plus 45 times 9.8 times 21 minus 0.5 times 45 times 16 squared. No idea what the answer is here. 0.5 times 45 times 8.3 squared plus 45 times 9.8 times 21. That's just the typing from the okay, I thought that was a squared for a second. Minus 0.5 times 45 times 16 squared. Did y'all get 5051? 5,051 and change? I'll write 5,050 to 3 sig figs, but I would take 5,051. In terms of part marks, I would probably go something like this. Half mark for that, half mark for that, 1 mark for that, 1 mark for that, 1 mark for the answer. Roller coasters. Mr. Dueck, I noticed this is an identical roller coaster to one we did in the examples, and I got the same answers. Is that going to happen on the test? No, I changed the numbers. In fact, I think this one worked out evenly. So I chose to let initial be here and final be here for part A. And I said KE initial plus PE initial equals KE final plus PE final. This one is a bit too easy because we're starting from rest. I'm pretty sure the roller coaster I gave you didn't start from rest. It was much more like this question where there was a VI that was not equal to 0 and you had to do a bit more writing to get whatever you wanted to find by itself. Because here I can say nope and I can say nope and I get mgh initial equals a half mv final squared. In fact, instead of writing a half, I'm going to write it as over 2. The masses cancel, and they want me to find the v. I'm going to times by 2, and then I'm going to square root. I'm going to get v equals the square root of 2g h initial. It's going to be the square root of 2 times 9.8 times 90, and I think I'm going from memory. Is it 42? Is that what you get? No? Yes? See? No? Yes? Some of you haven't done the quiz apparently. Okay. What did I make this one worth, Mr. Dueck? 2 marks. 1, 2, 3. I would probably go something like this. Half mark if I saw that. Half mark if I saw that. Half mark for the numbers, and a half mark for the answer. B. Top of the next hill is 50 meters high. How fast are we going there? So I said, okay, that's my final. Arnica, there's 3 ways to do this. The clever, easiest way would be to put the ground right there and pretend your initial height is 40 meters, not 90 meters. Anybody move the ground and do it that way? Just one of you. So I'm not going to solve it that way, even though that's how I would do it. The second method would be to let your initial be down here at point A, and that way potential energy initial cancels out. Who let the initial be at point A and then let final be at point F? I got 1. Okay, so it looks like most of you left your initial here, and in which case not that much is going to cancel. Only the kinetic energy initial. So that's all right, we can do this. It's going to be KE initial plus PE initial equals KE final plus TE final. And the only one that's 0 is we're starting at rest. It's going to be MGH initial equals a half MV final squared plus MGH final. Alexia, do the M's cancel this time? Yeah, so I'll take that. You didn't have to step on the scale before going on the roller coaster. They want me to find this. I guess first I need to move this over. I'm going to go GH initial minus GH final, and that equals V final squared over 2. Or 0.5 V final squared. You could go divide this whole thing by 0.5 and then square root, or you can times everything by what? How to move the 2 over, Ryder? Now, when you do that, Ryder, you're going to have to put this whole thing in brackets and times the 2 like that. Because everything gets multiplied by 2, the same way everything would get divided by 0.5. And then how do I get rid of a squared? Square root. So that made this one a little trickier. I don't know if we've done one just like this before or not. It's going to be the square root of 2, 9.8 minus 90 minus 9.8 times. Wow. Let's try this all again, Mr. Dueck. 9.8 times 90 minus 9.8 times 50. I think that's the right heights, is it, Mr. Dueck? So, 2 bracket 9.8 times 90 minus 9.8 times 50, close bracket, square root of that, and I think this one worked out dead even, 28, no matter which way you did it. I would have moved 0 to the top of the 50-meter hill, and then H initial is only 40 meters, not 90 meters. You can get there in a lot less writing. This one is worth 3 marks. I would probably go something like half mark for that, half mark for that, Half mark for that. Half mark for the numbers, and then 1 mark for the answer. Then I would turn the page. Or we turned the page? I think we have already. How much work is done? So work is force times distance. It's going to be 130 times 70. What silly mistake have I just made? Yeah. Okay, don't fall for that. 0.7. So it's going to be 130 times 0.7, which I'm pretty sure is 91. I think 13 times 7 is 91. No, yes? Yep, okay. 1 mark. How much potential energy is stored in the bow? Is the answer mgh? No. Every year I have some kids, they use that mass and they pretend that this distance here, the 70, is a height. No, 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 no. How much potential energy exactly is a number stored in the bow? Got to be 91 joules, baby. Suppose it has a mass of, nice try, 0.0186 kilograms. What's the maximum speed the arrow can leave the bow? What we're really saying is this: all of the stored potential energy is going to get turned into what kind of energy, Salman? Yeah. I can argue that 91 is going to equal a half mv squared, although I wrote it as mv squared over 2, and now I can get the v by itself. V is going to be 2 times 91 divided by the mass, 0.0186 square root, which is going to be 2 times 91 divided by 0.0186 square root. It's going to be really close to 100. 98.9, is that right? Which, yeah, for a high-powered bow, they can go around 100 meters per second, which isn't faster than the sound barrier, but it's faster than a human can throw by a long shot. 98.9 meters per second. If you got that right, 2 out of 2. Otherwise, I would probably go a half mark if I saw that. A half mark for that. Half mark for that. And a half mark for the answer. We have a bonus question. If the arrow only leaves the bow with a speed of 54 meters per second, how much energy was lost to heat? So again, I'm going to start off with conservation of energy, G. But this time I'm going to include heat. Now, when I release this bowstring, there's no more stored energy in the bow. The potential energy goes to 0. And before I released anything, nothing was moving. So I have that. I want to get the heat by itself. How am I going to get the heat by itself? I think I'm going to minus the KEF over. I'm going to subtract this over to that side. So I'm going to get the initial potential energy, which was 91 joules, minus a half mv final squared. That's what equals heat. It's going to be 91 minus 0.5 times 0.0186. Was that right, Mr. Dueck? Yep. Times 54 squared. So it's barely going half the speed. 91 minus 0.5 times 0.0186 times 54. Don't forget this. I got 63.9. Anybody else? Of that 91 joules, only 91 minus answer button, only 27.1 went into making the arrow go fast. The other 63.9 went into sound and heat and other dissipative energies. Can you give yourself a clear score out of 23? Normally I would collect these. Oh, there's a yawn. But I want you to hang on to these in order to study. Give me 1 second, please.